Okay, let's go over exam 4. So this is the final exam. This review is posted on Canvas, as well as a answer key that will soon be posted. And then I will include this video as well. So this first question says, a soccer ball is kicked from the ground at an initial velocity of 48 feet per second. The height of the soccer ball is represented by the equation h of t equals negative 16t squared plus 48t. So the first thing we're asked to find is the maximum height of the soccer ball. So if you remember, the height of the soccer ball follows the quadratic path. Okay, so the maximum height of the soccer ball is going to be the vertex. The vertex means that we need to find the x value and a y value. So we find the x value first and then plug that x value into the function to find the corresponding y value. So to find the x value, first, let's go ahead and find that negative b over 2a. So negative 48 divided by 2 times my a, which is negative 16. So that's your x. If you calculate that out, we get 1.5. Now 1.5 is not our maximum height. It is the time it takes to get to our maximum height. So that is the x value of the vertex. To find the y value of the vertex or the actual maximum height, we need to just plug that 1.5 into the function. And actually, I don't have an f or an x. In this case, it's an h. So h of 1.5 equals negative 16 times 1.5 squared plus 48 times 1.5. And that gives us, h of 1.5 is 36. So now we're going to answer the question that they asked us. So they want to know the maximum height of the soccer ball. We will just say the maximum height of the soccer ball is 36. You can add something onto this. So if they want to know the maximum height of the soccer ball and when it occurs, you can say the maximum height of the soccer ball is 36 feet at 1.5 seconds. That's something you can do. And then you have the question answered fully. So they actually didn't ask for when the maximum height of the soccer ball occurs. I added that in just so that you know that extra part. Okay. Now, after finding the vertex or the maximum height of the soccer ball, another question that can be asked with this situation is how long the soccer ball is in the air. So if you think about what that would be, so we come up and then down. Right there is where we hit the ground, so we are no longer in the air. So this is our time, and we're going to just try and figure out when is our time, what is our time when our height is 0? Well, our height is h of t, so we are really just finding the x-intercepts. So we set that equal to 0. We're going to factor, and we get t equals 0 and 3 seconds. Now 0 doesn't make sense in our situation because if at 0 seconds you're not in the air at all. So you haven't even gone up. So that means that our ball is in the air for 3 seconds. And that has our question all the way answered. Okay, I really appreciate writing out your answer in words so that you show exactly what you were trying to find. Okay. The next question is, how high is the ball after 2 seconds? So I evaluate this question in my head. So I ask myself, what are the pieces of information I have? And what am I trying to find? So how high is the ball is what you're trying to find. How high is the ball is my h of t, or my y value. After 2 seconds is my t value. That's our x, or independent variable. So we know our t, we're trying to find h of t. In fact, we're trying to find h of 2 because we know that t is 2. So I'm going to plug 2 into my equation, like that. And then I calculate that out. I get h of 2 equals 32 feet. So that means, answering the question, how high is the ball after 2 seconds? The ball is 32 feet after 2 seconds. So there we go, I've answered that question. Okay, and then the last question on here says, when is the ball 30 feet in the air? So when is my independent variable, my t, and 30 feet in the air is my h of t. So we're going to switch up the equation. My h of t I know is 30. And then my equation equals negative 16x squared plus 48x. And I need to solve this quadratic equation. Okay, to solve this, I'm actually going to add the 16x squared over. So I've got 16x squared. I'm going to subtract the 48x, and plus 30 equals 0. Now, I'm just going to look, can I divide the equation by anything to make the numbers a little bit simpler? In this case, we could divide everything by 2. I can do that because I have an equal sign. So I have 8x squared minus 24x plus 15 equals 0. On the answer key, I actually didn't do that. I just plugged 16, negative 48, and 30 into the quadratic formula. So it actually doesn't matter whether or not you simplify. I just wanted to try it a little bit easier. So here I have x equals negative b, so that's positive 24, plus or minus the square root of b squared, so 24 squared, minus 4 times the a times the c, all over 2 times my a. So I'm going to simplify the inside of the square root on this. I get x equals 24 plus or minus 24 squared minus 4 times 8 times 15. I actually just plugged that right into the calculator and got the square root of 96 all over 16. Now I can simplify the square root of 96 if I want to. And normally on a quadratic function you would need to. But because we're just trying to find the actual time, I'm just going to plug this into the calculator and get approximations of when that time is. And I'll just round to like the nearest tenth. So if I go 24, let's see, 24 plus the square root of 96 over 16, we get approximately 2.1 seconds. And if we go 24 minus the square root of 96 over 16, that is approximately 0.9 seconds. So when we're asked, when is the ball 30 feet in the air? The ball is 30 feet in the air at 2.1 seconds and 0.9 seconds. There we go. So that is how we figure out the time when we're given the height. Let's move on to the next question. Question 2 just has us use the quadratic to solve the quadratic equation using two different methods. Now I am going to give you a little hint on these. When we are doing this problem, you will be given the exact same problem for completing the square and the quadratic formula. And then you have to show the steps, the correct steps to solve them. Okay? You can't just write the answer for both. The points are going to be given to you based off of your work, not the correct answer. Though the answer does need to be correct, but the steps hold way more weight than the answer does. Okay, so when we are solving this quadratic equation by completing the square, we need to first take my equation, and I'm going to subtract the 45 over to the right side. And then we will complete the square. So to complete the square, we take the 16, divide it by 2. That's 8. And then we take the 8 and square it, and we get 64. So 64 is the value. I picked a color that's not much different. There we go. 64 is the value that gets added to both sides of the equation. Okay, once we have that value that we can add to both sides of the equation, we will want to factor, and factoring is easy. It's the value after you divided by 2. So we're going to factor into the binomial, and then we are going to go negative 45 plus 64 would be 19. All right, sorry, my dog decided it wanted to eat right now, and I don't have time to wait for him, so we're just going to, you might have to listen to the puppy eat. Okay. So there we go. We are going to take the square root of both sides. Don't forget that when you do take the square root of both sides of an equation, we need plus or minus. So we get x plus 8 equals plus or minus the square root of 19. And let's just subtract the 8 from both sides, and we get x equals negative 8 plus or minus the square root of 19. Okay, completing the square is actually a pretty easy process if you have a 1 on your x squared and your middle term is a clean, even number. Okay, so that would be solving an equation using complete the square. The reason I put two different problems here is so we can see two different varying difficulties. So if I do have to solve the problem or a quadratic formula, solve an equation using the quadratic formula, wow. I get my A, my B, and my C. And we did this up above, but I'm just going to write the formula so you can get a reminder of what it looks like. Okay, quadratic formula might be something that you want to put on your note card. So we're going to go negative b, so that's positive 4, plus or minus the square root of b squared, so negative 4 squared is 16, minus 4 times a times c, all of that over 2 times my a. Okay, so then we're going to simplify the square root. 4 times 3 times 9 is negative 108. So 16 minus 108 over 6. And then we get 4 plus or minus, let's see, 16 minus 108 is negative 92, all divided by 6. Now on the last test, I saw a problem that I really didn't like. And it was that students tried to cancel this 4 and the 6 right here without canceling both of the terms. So in order to cancel, every term has to be able to cancel. So what I do to solve that is I'm going to reduce my square root. But while I do that, I'm going to rewrite over each of my terms over the 6. Let's see. 92 is, let's see, that's 4 times 23, and we can pull out the 4 and the negatives. That's 2i square root 23 over 6. Now, if I break up each term and divide 6 into each one, then we can reduce individually. So we've got 2/3 plus or minus 2 over 3 2 over 6 reduces to just 3 in the denominator. So that's 23 over 3. And that is our final answer. If we were to use complete the square in that process, we would still get the same thing. Okay, that is solving equations or quadratic equations. Just remember, we have multiple ways to solve quadratic equations. We can factor, we can use the complete the square process, we can use the quadratic formula. If they're in the right format, you can use the quadratic or the even root property. So 4 different ways really to solve a quadratic equation. Okay, question 3. We're only on question 3, yikes. Okay, it has us graph the quadratic function by identifying the vertex and the intercepts. And we actually don't have to worry about the equation of the axis of symmetry. That is for college algebra. So we're just going to find the vertex and the intercepts. Okay, let's start with the vertex here. Remember, we've already done the vertex. It is, we need to find the x value, which is negative b over 2a. So negative 8 is 8 over 2 times 9a, that's 2. 8 over 2 is 4. No, 8 over 4 is 2. And then the y value of my vertex is found by plugging that x value into the function. 2 times 2 squared minus 8 times 2 minus 10. Let's see, that's 4, 8. 8 minus 16 is negative 8. Minus 10 is negative 18. So there's the vertex. A pretty simple process. Okay, now we're going to find the x-intercept. So to find the x-intercept, we just set our quadratic function equal to 0. I'm going to divide both sides of my equation by 2. So that's x squared minus 4x minus 5 equals 0. I factor that. Goodness. We got that. So we get x equals 5 and negative 1. Next, to graph, we need to find the y-intercept, and that is luckily the easiest part. So we're just going to plug 0 in for our x, which you don't even have to write this down. If you can see it without writing it down, you should be able to see that y equals negative 10. Now, I'm going to graph this. I do need to go to negative 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So my vertex is 2, -18. My x-intercepts are 5 and -1. And my y-intercept is -10. So if I sketch this out, we go down here, and then up there, and that is our quadratic function. Okay, question 4. Solve the absolute value inequality. Remember, the solution to an inequality is the interval notation and the graph. So that's what we need to find, the interval notation and the graph. So when I have an absolute value, if this were x minus 1 equals 6, then we would have x minus 1 equals 6 and x minus 1 equals -6. But because I have an inequality sign, I'm just going to put the inequality sign instead. But on the -1, since I'm multiplying that 6 by a negative, I have to flip the direction of the sign. So I have two possibilities here of my solution. Either x minus 1 is greater than 6, or x minus 1 is less than -6. So I solve each one of those. I get x is greater than 7, and x is less than -5. So if I put each of those on a number line, here's -5 with an open circle. Here's 7, also with an open circle. And we have x is greater than 7 and less than -5. So I've got my graph down. Now I just need the interval notation that goes with the graph. So we've got -infinity to -5 parenthesis union 7 to infinity. And that's our answer. Absolute values, just remember that there are usually two solutions. There are a couple special cases, but usually you get two solutions. Okay, let's take a look at solving the inequality that is a rational inequality. So we need to write the solution in interval notation and graph. Okay, so this one's a little bit harder. The first thing that we need to do is I'm going to factor this. So I'm going to take my denominator and factor that to x plus 1. X minus 1 is less than or equal to 0. Okay, then we are going to get our critical values, or our boundary points. So let's get the boundary points from the denominator first. Okay, so our boundary points from the denominator tell us that the denominator cannot equal 0. So that means that x cannot equal -1 or 1. Okay, if I'm going to go and put that on a number line, those will go on my number line open. They will always be open when they come from the denominator, because the denominator cannot equal 0. So even though it says greater than or equal to 0, we actually can't equal 0 in our denominator. So keep that in mind. That's very important. Then we're going to take a look at the boundary points for the numerator. The boundary points from the numerator take our x plus 7. Let's find where that equals 0. So that is at -7. Now that goes on the number line according to our inequality sign. So because this is less than or equal to, I can be equal to 7. So I shade that one in. So the denominator and the numerator have two separate ways to put the answers onto the number line. Okay, now we have our boundary points. We just need to figure out what each region is formed by my boundary points. Is it positive region or a negative region? So we're going to pick some test statistics. In this case, I'll start with -10. I'm going to plug -10 into this original equation. -10 plus 7 is -3. -10 squared is 100 minus 1 is positive 99. So a negative over a positive is a negative. So that entire region to the left of -7 is a negative region. Its y value is negative based off of its x value. Okay, in between -7 and -1, I'm going to pick -5. -5 plus 7 is positive 2. -5 squared is 25. Minus 1 is 24, so that's a positive as well. A positive over a positive is a positive. Then I'm going to pick something between -1 and 1. I will pick 0 because it's easy. 0 plus 7 is positive. 0 squared minus 1 is negative. A positive over a negative is a negative. Then I'm going to pick something to the right of 1, that's 10. 10 plus 7 is 17, that's positive. 10 squared is 100 minus 1 is positive. A positive over a positive is a positive. Okay, so that's my sign chart. That tells me which regions are positive and which ones are negative. Now, we look at our original inequality. It's saying we want to find all the values less than 0. Okay, so all the values less than 0 would be negative values. So that means the regions that work will be my negative regions. Okay, now that means that our actual inequality or interval notation is going to be from -infinity to -7 with a bracket. Union, a parenthesis, -1 to 1. And there is our answer. Okay, so up to this point, every single question that we've seen, with the exception of the absolute value inequality, will be written types of questions. They're longer. You've actually got to write the solutions out. You can't just do a small portion and have that be a multiple choice question. So just keep that in mind. Now we're going to see some quick, easier things that can be done, which will be more likely to be multiple choice if it's on there. So this question, number 6, says write the logarithmic equation in exponential form. I'm not sure why there's an S there, but there's not supposed to be. So we'll just scribble that out. Okay, so if we're rewriting this as an exponential equation, we're going to start with our base and hook that around. So that becomes 64 to the 7th power equals, that x comes out, x. And that is just rewriting the equation in exponential form. Okay, b is a little bit harder. There's no base on my logarithm. The inside of the logarithm is 1 over 1,000, but if there's no base written on my log, that means it's log base 10. So if we hook that base around, it becomes 10 to the -3 power equals 1 over 1,000. We're not solving anything here. We are simply rewriting the format of the equation. Okay. And same thing with question 7 here. This says rewrite the exponential equation in logarithm form. So it's the same thing. We start with our base, hook that around. That would be log base 5 of x equals, then our exponent comes out, equals 8. Okay, The next three problems are going to have us use our rules of logarithms. So just a quick reminder about the rules. If I have log base anything with a 1 inside, that simplifies to 0. If I have a log with a base and what is inside the logarithm is the same as my base, that simplifies to 1. And if I have a logarithm with a base and then inside the logarithm is the same base but to another power, the base and the log cancel out and that is just n. So those three rules of logarithms, if you can recognize those really quick, you can do these problems really fast just by looking at them. So for example, I have log base 9 of 81. Well, I can write 81 as a base with 9. Okay, so that's log base 9, 9 squared. So the 9s and the logarithms cancel out. That just gives us 2. This rule, log base 5 of 1, according to the rule, if 1 is inside the logarithm, that would be 0. And if my logarithm with a base and then the inside of the logarithm are the same number, then that becomes a 1. And that's just simplifying those expressions or evaluating those expressions using your rules of logarithms. Okay, those last couple problems would all be example of multiple choice as well as these next two. So if we look at this question, it says find the center and the radius described by the equation and then graph. Okay, so you actually are only going to really need to know how to find the center and the radius. Good thing is this is a very simple thing to do. I think you'll like this. So the center is just the point from inside the parentheses, kind of like finding the vertex in vertex form. So if I have x plus 1, what makes x plus 1 equal to 0? That would be negative 1. And what makes y minus 6 equal to 0? That's positive 6. So that is just the center of my circle. The next thing you can find with this equation is the circle's radius. Also very simple. This is your radius squared. So if my radius squared is 25, what squared is 25? That would be 5. So there's a center at negative 1, 6 and a radius at 5. Now the problem does ask us to graph it. So let's see, 1. I'm just going to go make a little coordinate. I have the center at negative 1, 1, 2, 3, 4, 5, 6. And then from my center, I'm going to go up, down, left, and right, 5 units, and make a circle. So let's see. Up, 1, 2, 3, 4, 5. Left, 1, 2, 3, 4, 5. Down, 1, 2, 3, 4, 5. Right, 1, 2, 3, 4, 5. My tick marks aren't perfectly spaced out, so my circle's going to look kind of funny. But there you go. So there is our circle. The most important thing for you is being able to find the center and the radius. Okay, so that is actually from section 39. This next one is from test 1, so from a long time ago. It says find the slope between the 2 points. This is a multiple choice type of question. But there is a formula that corresponds with it that you do need to know, so you probably want to get this memorized. Whoops. My guess is that you do already have this memorized. It's one that you've used a lot, we've used a lot. It's kind of one that you've seen growing up. So the slope is equal to the change in y, so y2 minus y1, over the change in x, x2 minus x1. So we're just going to go 12 minus 9 over Negative 9 minus negative 6, so plus 6. So that gives us 3 over negative 3, so our slope is negative 1. And there we go. It's that simple. You just put them in the formula and get the answer. The next question is going to be a little bit harder now. This would be an example, if it is on the test, it would be an example of a written question. Either 1, 2, or maybe even 3 of these questions would be on the written part. So we're going to use this graph here to answer the following questions. So the graph will be the star of the show here. The first thing says, write the equation of the line represented by the graph. So here's my graph. I have a bunch of points on my graph. The first thing we want to do when we're trying to write the equation of a line is we need to find the slope. So the first thing when we're writing the equation of a line is we need to figure out what the slope is. We have a lot of different ways to find the slope. If we have a graph, we can just do the rise over the run. If you have 2 points, you can just find the slope between the 2 points. If you have a parallel line, it's the same slope. Or if you have a perpendicular line, it's the opposite sign and the reciprocal. So in this case, we have our line. The slope of our line is rise, that is negative 2, and a run, that is 1. So our slope would be negative 2. So that's the very first step in finding the equation of the line, is find the slope. The second step in writing the equation of the line is putting all the information into point slope form. So here's point slope form. Okay, so first we find the slope, then we put it into point slope form. So we can pick any point here. Let's just pick this point right here. That's the point 0, 5. So I'm just going to go y minus the y point is equal to our slope, which is negative 2, times x minus the x point. Now you might notice that's the y-intercept, and then you can just go into slope-intercept form. But I'm just trying to show you how to go about these problems. Now the next thing I want to do, so step 3, is we want to solve for y. Okay, so the last thing I do is I take all my information after it's put in and I solve for y. So I'm going to distribute that negative 2 through. Negative 2 times 0, 0. And then add the 5 over. So that's negative 2x plus 5. And we have our equation solved. So this is the equation of the line that is represented on my graph. Okay, now the next question wants us to write the equation of the line passing through the point 5, negative 9. So that's some important information. I'm going to highlight it. And is parallel to the line in the graph. So our line somewhere here is going to be parallel to this line. I don't know if it's above or below, but it will be parallel. So we have to first, just like we were doing before, find the slope. Okay, so it's parallel to our blue line. We know our blue line slope is negative 2 from the previous problem. So if the parallel line's slope is negative 2, then the parallel line is also negative 2. Okay, so that is our slope. Our slope is that negative 2. Okay, after we find the slope of our line, just like before, we're going to plug into the point slope form. We have our point, 5, -9, and we have our slope is -2. So I'm just going to plug that in. -9, or minus -9 is +9. -2x minus 5, because our x value is 5 in the point they tell us. Okay, so that's the next step. Then the last step here is to just solve for y. This is usually the hardest step. It's not so bad when you have nice clean whole numbers, but if you get fractions, this process can be kind of tricky. Looks like we're not going to have fractions here, so that's nice. So we've got y plus 9 equals -2x plus 10. And then let's subtract the 1, -2x plus 1. So there we go. That's the equation of our line that is parallel to our line. It doesn't ask us to sketch it at all, but if you wanted to, you could kind of see our y-intercept is at 1. We're going to go down to run 1, and it would be a parallel line. So you can kind of see how it is parallel, and that kind of helps you make sure you did the problem right. Okay, the last problem on here is write the equation of the line passing through the point 5, -9. That sounds very similar to B, okay? But this line is perpendicular to the line in the graph. So the line in our graph has a slope of -2. The first thing we want to do is find the slope of our line. So the first thing, let's find the slope. So the perpendicular slope is -2. So that means that our line slope is the negative sign. So instead of negative, it's a positive. And the reciprocal of 2, which would be 1/2. Okay, so that is our slope. Now the second thing that we need to do is put the information into our point slope form. And you can write these 3 steps down. That's fine. If that helps you, remember, go for it. So we have y minus -9 is +9 equals my slope, which is 1/2, times x minus 5. Okay, so I've got y plus 9 equals 1/2 x minus 5/2. Oops, that is actually step 3. We're going to solve for y. So I'll kind of come over here. We need to add that 9 over. So that's a -9. Let's make that 9/2 so that we can have a common denominator. And -5/2 minus 18/2 is -23/2. There we go. So that is the perpendicular line to our line. So there are 3 really good examples of what you can do writing the equation of the line. If there was a problem like this, it would definitely be a written type of problem because there are a lot of steps and moving parts to these. All right, let's move on to the next page. This next problem, this would be a multiple choice problem. And I know there's a lot of work to this, but there's not like any formulas to memorize or anything. So you can solve this system of equations using any method you prefer. If you like substitution, then use substitution. If you rather use elimination, which I would rather do, you can use that. If for some reason you know how to solve this using a matrix and you want to do that, go ahead. So you just need to solve this equation however you like. So I'm going to do elimination, and I like how these are set up right there. So I'm just going to multiply this top equation by -3. By multiplying through by -3, let's see, that's minus 9y, is it creates variables that are the same coefficients but opposite signs on my x's. So if I were to add the equation, we get -16y equals 16 and the x's go away. Then we can just divide both sides by -16 and we get y equals -1. Now we're not done with the problem. If this were a multiple choice, there would be a drop down for x and a drop down for y. So if you get y equals -1, then we're just going to plug -1 in. Any equation will work, but the one with the smallest numbers is the one I want to use. So we're going to plug that -1 in here. So we get 2x equals 8. So x is 4. So our solution is x is 4, y is -1. Okay, these problems are, they're going to assume that you can solve a system of equations in college algebra. They don't even do a section, or at least they didn't used to, where you have to actually solve a system of equations. They're going to just go right into the matrices, knowing that you can do this. So make sure that you're comfortable with the system of equations before you take college algebra. Okay, let's go on to the factoring. This is a good one. We've got 3 factoring problems. Factoring is one of the major skills that you should have taken away from this class. Okay, and I know you've factored a lot and you're sick of it, but you're just going to be doing it as long as you're in math. So keep that in mind. Okay, so we have here 4 terms, so that means we have to factor by grouping. When we're factoring by grouping, we're going to take the first 2 terms and the last 2 terms, and if that doesn't work, we'll rearrange and then retry. But usually if you have them in decreasing powered order, factoring by grouping will work. So on this first one, the GCF is x squared. So from the 2 terms, I'm going to pull out an x squared, and I'm left with x minus 10. On my second 2 terms, my GCF is -4. So if I go -4x divided by -4, that's x. 40 divided by -4 is -10. Okay, now each of my groups has a common factor of x minus 10. So I'm going to pull the x minus 10 out. And that gives me x minus 10 times x squared minus 4. Okay, so then the last thing I need to do is just factor this x squared minus 4. That becomes x plus 2, x minus 2. Okay. So there are factoring problems on the multiple choice and on the written. That is how important they are. So I can't quite remember, but this one like this would probably be multiple choice. It's pretty simple. You can do this problem pretty limited amount of work. Okay, on question B, I have 12x squared plus 48x minus 27. So I'm going to look for first a greatest common factor. In this case, my GCF will be 3. So that gives me 4x squared plus 16x minus 9. I'm just double checking that I factored each of those right. Okay, good. Then I'm going to take the 4 and multiply the 9. You can factor this however you like. This is just how I like to do it. It makes the most sense to me. So x squared plus 16x minus 36, which are the factors of 36 that have a difference of 16 is 18 and 2. Then we just need to divide each of your factors by 4. So that gives me 3x plus 9/2 and x minus 1/2. Okay, let's bring each of our denominators up. Because we're factoring, we're not solving, we're factoring, so we do need to bring those denominators up. So there we go. Okay, that's a lot more work than the previous one. That would definitely be a written question if they had one. Okay, and then the last one here would be like C. The C is actually, I think, the easiest one out of all of these. This is in the form a squared minus b squared. So my a would be 10a, and my b would be 3b. So we have 10a plus 3b and 10a minus 3b. And that is factored. You do want to make sure that each one of your factors are prime. If you did this rule and one of the factors could be factored even further, make sure to do that. Okay, so there's our factoring problems. I said this was system of equations, but if you are not comfortable with factoring, you better get comfortable at it before you go on to college algebra, because it's going to be something they just assume you know how to do. The teachers won't spend time talking about how to factor. They're just going to factor. So keep that in mind. That's important. Okay, question 14. On the test that this was on, this question was missed quite a bit. We need to, there's a couple important things as I'm going throughout this problem I'm going to talk about, so make sure you're paying very close attention. The first thing we need to do before we find the restrictions or before we do anything else is just factor the denominators. So in this case I have x plus 3, x minus 3, minus, that minus is so important. Then we have this x minus 3, equals 4 times x plus 3. Okay, I just adjusted where the problem was so it looked a little better. Now we can find the restrictions. So that is what makes the denominator equal to 0. So x plus 3 can't be 0, so that means x cannot equal negative 3. X minus 3 can't be 0, so x can't be 3. We already have the restriction there and there. So there are the restrictions. Okay, now that we have the restrictions, we need to find the least common denominator. So in this case, our LCD is x plus 3, x minus 3. So I'm going to go through and multiply every single fraction or every single term by the LCD. And I'm going to cancel out all of the fractions. So here, everything cancels. Here are the x minus 3's. Here are the x plus 3's. So I'm left with 6 minus 2 times x plus 3 equals 4 times x minus 3. The biggest mistake I saw on these problems is not distributing the minus sign on the 2 through the problem. So if I distribute, I have to go negative 2 times x and negative 2 times positive 3, which is negative 6. Then I have this 4 through 4x minus 12. Okay, I'm going to solve this so that 6's cancel out. We have negative 2x equals 4x minus 12. Let's just subtract the 4x over. So we've got negative 6x equals negative 12. And divide both sides by negative 6. we get x is 2, which is not one of my restrictions, so that is our answer. Yay. Okay, last 2 pages here. We want to rationalize the denominator and simplify this. This question also was not a very successful test question. And the thing is, it's actually really simple. I think the problem with this question was it was evaluating another student's work, which kind of threw some of you off. So I want to just show you how to do this problem without all the extra stuff to it. So we need to multiply the top and bottom by the conjugate of the denominator. The conjugate of the denominator takes the numbers and the sign in between them is changed. Nothing else, just the sign in between them. So if I do that, I'm actually not going to distribute the 8 through yet. I do want to FOIL here, so 5 times 5 is 25. Square root of 7 times the square root of 7 is 7. So that gives us, sorry about that, let's see, 8, 5 minus the square root of 7 over, that would give us 18. And then I'm just going to reduce the 8 and the 18. So 8 goes into 18. Let's see, that's a common factor of 2, so that's 4 over 9. So you can keep your answer as 4 times 5 minus the square root of 7 over 9, having that reduced. If you want to, you can also write your answer 20 minus 4 square roots of 7 all over 9. Okay. One thing that you cannot do is reduce a single term. This 4 is being multiplied by everything, so that's when I can reduce. Or the 8, sorry, is being multiplied by everything, that's when we can reduce. But if I had like a 20 and a 9 and those reduced, you couldn't just cancel there because of the subtraction sign. So either one of these answers is a fully correct answer. So there we go. All right, the next question is to write the quadratic equation in standard form with the given solution set. All right, so we have 2 things happening here. We have x equals 5 minus the square root of 3, or x was equal to 5 plus the square root of 3. If you were to write those as their factors, it would be x minus 5 plus the square root of 3 and x minus 5 minus the square root of 3. So I'm going to take those factors and multiply them. X minus 5 minus the square root of 3. And when I distribute or multiply them, I'm going to go first, middle. I guess there's no first, outer, inner, last here because it's a 3 by 3. So I'm just going to distribute this x times each thing, then this negative 5 times each thing, and this negative 5 times negative square root of 3 is plus 5 square roots of 3. Then the square root of 3 here is plus x square roots of 3 minus 5 square roots of 3. The square root of 3 times the square root of 3 is 3, but we have a negative sign on there. Okay, so those cancel out, the x square roots of 3. The 5 square root of 3 minus the 5 square root of 3 will cancel. So I'm left with x squared minus 10x. 25 minus 3 is plus 22. And there we go. So that is the polynomial with the given zeros. Okay. So this next problem, just really quick, there is a typo. This 9 should say 5, and this 9 will be 5. It was changed from a previous semester's test review. So, all right. So I have f of x equals 5 to the x, and g of x equals log base 5 of x. So you can use all the kind of common things that happen with these. We have our function is going to go through the point 0, 1. Every exponential function goes through the point 0, 1 and the point 1, whatever the base is. In this case, our base is 5. The domain of every exponential function, basic exponential function, is negative infinity to infinity, and the range is 0 to infinity. And there's a horizontal asymptote at y equals 0. So if we were to sketch that out, we go through the point 0, 1, 1, 5, and a horizontal asymptote. Goodness. Try and get this a little better. There we go. There's our exponential function. Now drawing a logarithm function is easier than having to remember that, because everything you need to know to graph a logarithm function is that you just switch x and y's. Whoops, there's supposed to be 1 there. So instead of going through the point 0, 1, you're going to go through the point 1, 0. Instead of going through the point 1, 5, you're going to go through the point 5, 1. The domain is negative infinity to infinity. So that becomes your range, because your domain is x, your range is y. Your range, which was your y, becomes your x. So your domain of your new function is 0 to infinity. Then instead of a horizontal asymptote at y equals 0, you just replace your y with your x, and that means there's a vertical asymptote at x equals 0. So we've got the point 0, or 1, 0, 5, 1, and we have our graph. And that's it. You graph your exponential logarithmic equations on the same graph. Okay, let's take a look at the very last page of this test review. So the first question tells us to use u substitution to solve the equation. So I'm going to let u equal the square root of x. I will have u squared equal x, and then I will replace that into the equation. I'm actually going to subtract the 72 over. Then we're going to factor, that's x plus 8, or u minus 8, u plus 8, u minus 9. So that means u is negative 8 and u is 9. So if we replace our u back in, we have the square root of x equals negative 8, and the square root of x equals 9. Now we can't have our square root equal a negative, so there's no solution from that. We can have our square root equal 9, so we get x equals 81. And if we plug that into the original, we get 81 minus 9 equals 72. So it works out. Now I went through that one kind of fast. If that is even on the test, it would be a bonus. So there you go. Let's take a look at 19. 19 is actually a drop-down multiple choice or computer part. It has 4 different functions. With those 4 functions, 4 equations. They are definitely not functions. 4 equations. With those 4 equations, you need to match what the name of that equation is and what the graph of that equation looks like. Okay, so if I'm looking at A, it's y minus 5 equals 2 times x plus 3 squared. Okay, that is a parabola. So let's just write D, a parabola. Okay. And the graph of the parabola would be also D. Okay. Okay, so for B, we have x plus 2 squared plus y minus 3 squared equals 16. That is a circle. Okay, and you should know what a circle looks like. The graph is C. So C is the graph on that one. And so it will just have a drop down and it will have you match it. I couldn't obviously do a drop down matching on this, so this is my solution. C, I have x minus 7 squared over 16 minus y plus 1 squared over 9 equals 1. That minus is telling me that we have a C hyperbola. And the graph of the hyperbola is A. That's what the graph is on that. And then the last one by process of elimination, but you don't have process of elimination on yours, I don't think. Well, you might. I don't know. Since it's the same kind of function, but with a plus sign in between, this is called an ellipse. And we'll learn why and stuff, but essentially, the minus sign is the hyperbola, the plus sign is the ellipse. The other two are kind of your basic ones that we've already learned. So the ellipse is the graph of B. So there we go. So there are our conic sections, and this multiple choice question is actually worth double the points. So it's pretty simple if you know it. If you know how to match everything up, you're going to be great. All right, so there's our test review. Good luck taking your test. I hope that you are rewarded according to your efforts.